Hi everyone and welcome to our channel. Today we are going to see one of the C concept, which is nothing but the pointers concept. We know that pointer is also a variable, but it stores the address of another variable. And just like a normal variable, we need to declare the pointer before using it. And the syntax you need to follow is the type of the pointer, okay? Means the type of data that pointer variable is pointing to and the pointer variable name. You need to put a star. Why? Because in order to differentiate a normal variable and a pointer variable. See, if you written like this int p, it is a normal variable. But if you written like this int star p, it represents it is a pointer variable which is going to point to a variable of integer type. And as you can see, the pointer variable can be of any type, and the variable or the value it stores is nothing but only the address, which is nothing but long hexadecimal number represents the address of memory. For example, you can see you are having some integer data 10, the variable name is a, and you are having some character a and the variable name is c, for example. P1 is a pointer referring to it, P2 is a pointer referring to it. If they are referring to the different variable types, but both hold the same type, both hold the same content, which is nothing but what? Similar content, which is nothing but address only. Okay, this is the main advantage of using the pointers. Pointers are used in allocating and deallocating the memory, majorly in dynamic memory allocation, and to refer the variables indirectly. Now let's see some of the examples for them. See, I'm going to take, let me remove this header. We don't need this. Now see here, let me take an integer variable holding a value 10 and let me create a pointer variable star p, and we know that let me print the address, okay, the address of variable a, the address of variable a, right? We can print the address of variable a by using a pointer variable, right? So assign the address of pointer, assign the address of variable a to the pointer, means what? P equal to ampersand of a. Now you can see this is a variable a, this is a variable p, and it is referring to the variable a, right? P is a pointer variable which is referring to the memory location a. Okay, now observe here, p equal to ampersand of a, the address of variable a is what? P. And similarly, if you want to access the content present in the variable a, now let me copy and paste it here, the value, okay, or the content. The value of variable a is, you need to put a star in front of it, okay, to access the data. Now let me execute. Now see, okay, hold on. Now see, percentage d, right, backslash n. This is address, right? Let me take a long integer so that there will be no problem. And here let me take a percentage d, because it is an integer variable, right? So percentage d I had taken. Let me save this code and execute. Now you can see the address of variable a is this, and the content present in it is 100, which is nothing but this is variable a whose address is 6487572 and holding a content of 100. P is a pointer variable which is referring to the a. So that's why you can see this address will be stored inside the p variable. And see, when I print p, I got this address. When I print star p means what? The content present here is nothing but what? 100, right? Now let's see some more variants in the pointers concept. Now as you can see, the next thing was the null pointers, which is nothing but here we will initialize or we will assign the pointer variable with a null. Why? Because in order to protect it from unwanted memory access. For example, let it be my system. If I won't initialize, then by default it may access to or it may point to any memory in my system, right? For example, if it is pointing to some sensitive content or if it is pointing to some OS related content, it may damage my system, right? That's why the better programming practice is to assign the pointer with null initially. Okay, now let me tell you how to do that. See, before using it, I am going to assign it with a null, and after whenever I am going to use, then only I am going to assign an address to it. Now observe the same thing, there will be no change in that. Okay, it is a best programming practice. Okay, everyone should follow that. It's a best programming practice. And the next thing was, observe here, the double pointers is nothing but not only double pointers, triple pointers. Like this, you can extend this concept to any number of pointers. A double pointer is nothing but a variable which stores the address of another pointer. For example, this is variable a holding some content, and this is a pointer p1. This is referring to the variable a, and there is a pointer p2. This is referring to the address, or this is referring to the pointer variable p1. Now as you can see, p1 is referring variable a, p2 is referring variable p1. So p2 is a double pointer here. Why? Because p2 holds the address of another pointer variable, right? Just like you need to declare the pointer and use it, and this is the syntax for it. Now let's see an example for it. Okay, now observe here, let me create one more pointer, int, hold on, int double pointer means star star q equal to initialize me as null, and see, I'm going to take a q equal to, as you can see here, q equal to hold a minute, as you can see here, q equal to ampersand of p means what? P is a variable, pointer variable referring to a, q is a double pointer referring to variable p. Now the same thing I'm going to copy and let me paste it here. The address of variable p is what you can directly write as a q, and similarly the value of variable p is, you can write it as like this, see, star q. Okay, now let me execute this one, right? Have you got that right? The scenario will look like this. This is variable a whose address is 6487572 having a value of 100, and the p is a pointer variable referring to it, q is a double pointer referring to it, and this address is what? The address, hold on, the address is 6487560, right? Now see, this is the address of pointer variable p. Similarly, when I written the star q means what? The content at this location is star q. So which is nothing but what? This one, right? So you can get this one as same. Clear, right? In this way, you can create the double pointers. Not only double pointers, you can create any number of pointers, okay? Any level of pointers. And one more thing you need to focus on is, if you keep on increasing the levels, the tracing is difficult and the problem or the code will become complex, okay? And this is all about the pointers concept. And one more thing we are going to look today is this one, the dynamic memory management. Why we go for dynamic memory management is, for example, if we take an arrays concept, array size is fixed, right? For example, if you take a size as 10, and in between, if you got some requirement that you need to extend your size from 10 to 15, it is not possible. In between, if there is a chance that you should not consider some more elements, or you need to reduce the size, reducing the size is also not possible. So this is called static memory allocation. Even though you use it or not, your memory wastage will be done, okay, right? For example, if you taken 10 but you use it only 5, okay, 5 blocks of memory, then remaining 5 will be wasted. So in order to prevent that, we will go for dynamic memory allocation, which is nothing but whenever you need the memory, then only create the memory, okay? Now see, there are some functions for that. Malloc, Calloc are used to create the memory, and Realloc is used to extend the memory, okay? free is used to remove the memory. Now let's see each of them in detail. Malloc function, okay. Now let me take the pointer, okay. Now to create the memory, p equal to int star, it's nothing but typecasting, and malloc of, for example, I'm going to store 5 variables, okay, 5 elements, and each element is of type integer, okay, size of int, 5 into size of int. Okay, now let me save this code. This will create the memory, okay, like this. This will create 5 blocks of memory where each block can hold an integer variable. Okay, and this is pointing with p. Now let me check it out here. If p equal to null means what? Memory has not been allocated. Then I'm going to write the message as printf memory not allocated, okay, memory not allocated. And the next thing is what? If it is not null means what? Memory has been allocated. In that case, I'm going to write as, I'm going to take the variables, okay. Okay, before taking that, let me print out those default values, okay. Let me take I equal to 0, and okay, let me take as I, okay. Here I will take I equal to 0, I less than 5, I plus plus, and let me print out here printf %d backslash n, the content, okay, p of I, content I'm going to get. Okay, see, printf default values, right? What is the default values when memory has been allocated? Now you can execute. Okay, okay, malloc, right? We need to take this header file. Why? Because these functions are available in standard library. Okay, let me save this and now execute. See, the default values are like this. Means what? It will give garbage values. Okay, it will allocate 5 blocks of memory, and into that 5 blocks it putted some garbage values. And you can observe this one. See, if I written like this, p of 0 equal to some 10, p of 1 equal to some 20, some p of 2 equal to 30, p of 3 equal to some 40, and then p of 4 equal to some 50. Okay, now see, some 50. Now see, just hold on, let me write it down here. Okay, and let me copy and paste it here. After default values, I'm going to give the values. Okay, the values we considered. Okay, the values we assigned previously. Okay, now let me execute and show to you. See, the default values are the garbage values, but here the values we consider 10, 20, 30, 40, 50, right? And those will be stored in the memory location. In this way, you can create the dynamically memory allocation using malloc. Calloc function is similar to that, and here it takes 2 arguments. The first one is number of elements you are going to store and the size of each element. Okay, this is the syntax of calloc function. Let me save and execute here. The same thing, but one difference you can observe here is the default values will be stored as 0 only. Okay, every type means it is of integer type, then it will be stored as 0. Okay, if it is floating type, it may stored as 0.0, like that. Okay, the default will be not garbage, here 0, and then the values we consider are 10, 20, 30, right? Those will be printed as it is. And Realloc is another type. Here Realloc means, okay, let me remove out these things. Okay, default values concept. And see, by using calloc function, we created some memory and we stored some 5 values. Now my concern is I want to add some more elements, which means what? I need to extend the memory, right? So in order to extend that, I need to take p equal to typecasting int star, but before that Realloc is a function and it will take a void pointer. Okay, means what? Okay, let me remove this. It will take a void pointer, void star, and to the existing p, right? To the existing pointer is what? Existing pointer is p, right? To the existing pointer p, I need to increase my size by 10, means 10 into size of int. Initially the size is 5 and I am going to extend my size to 10. Okay, now see, I am going to add some more elements. Okay, now let me copy this, let me paste it here. Okay, here, right? After extra memory has been allocated, p of 5, some 110, p of 6, some 120, p of 7, some 130, p of 8, some 140, and p of 9, 150. Now as you can observe, first we considered only 5 elements. After I extended the memory to 10 elements and I kept the remaining 5 elements. Now let me save this. Now, okay, hold on. Why? Because we printed only 5, right? 10, right? Now you can observe. Okay, let me put a message also. Printf memory reallocated. Okay, memory has been reallocated. See, memory reallocated and the entire 10 values has been printed. Done. In this way you can extend the memory whenever you want using this dynamic memory allocation functions like Realloc. And the last is a simple function which is nothing but a free. Free is nothing but free of the pointer name, free of p, to free up the entire memory. And let me write a message, printf memory is deallocated. Right? By using this malloc, calloc, realloc, we can handle the memory dynamically, right? See, memory reallocated, consider the data and memory has been deallocated. Okay, in this way we can take, for example, after memory has been deallocated, okay, let me write as a p. Okay, let me consider p if possible, what it is going to print. Some memory is deleted, some number we are getting. Now let me write like this. Okay, okay, let me check after freeing, will we get, do we get null or not? We will check it again. P double equal to null, we will check. Okay, let me save here. Okay, I hope it will be deallocated just simply. Means there will be no pointer, I think so. Okay, this is all about the dynamic memory allocation. The way to handle the malloc, calloc, realloc, and free. Okay, and this is all about today's session. Keep on practicing this type of concepts with some examples. Thanks for watching. Please do like and subscribe for more videos.